All right, welcome to 3A, which is solving quadratics by factoring. So to factor, we need all the terms to one side first and keeping the a positive. Now I should probably talk about a. We have in a quadratic, the standard form is ax squared plus bx plus c, and that is going to equal 0. A, b, and c are always numbers. They're never letters, they're never variables. So first, we are going to move or combine all terms to the same side of the equal sign, keeping a positive. So I first look at the a term, and do I have an a term in do I have r squared anywhere else in the problem? No. So that 6 is positive, so I'm going to keep the 6r squared on the left side of the equal sign. That means I'm going to move all the other terms to the left side to join the 6r squared. So I'm going to subtract 39r. I'm going to rewrite this. So it's 6r squared minus 39r. They are not like terms. And then I'm also going to actually just add the 62 right away. The 1 and the 62 are like terms. So I'm going to have plus 63 equals 0. This is the A is going to be 6, the B is negative 39, and the C is 63. And that is in standard form. We're going to divide out the greatest common factor, so if there is one. There isn't always. So now we're going to look at each individual term, 6r squared, 39r, and 63. What's the biggest number I can divide out of all three? And that would be 3. I can divide each term by 3. And what you're going to do is you're undistributing it. You're going to put the 3 on the outside. 6r squared divided by 3 is 2r squared. 39r divided by 3 is 13r. 63 divided by 3 is 21. Now, the 3 that just got divided out, the greatest common factor, this is not a variable with it, so we don't have to worry about it at this point. What we do have to worry about is, can we factor the quadratic that's left? And so by doing this, we are going to look at when a is greater than 1. Really, the a, even if it's 1, you always do this. There's the shortcut. We're not going to worry about shortcuts. So we're going to multiply a times c. So the a in this case is 2, the b is negative 13, and the c is positive 21. We're going to do a times c, which is 2 times 21, and that's 42. I'm going to do the little x, it's 42. You do what two numbers multiplied a times c that add to b? So the b, we're going to add to b, and the b is negative 13. So what two numbers multiply to 42 that also add to 13? If you can't think of this, write it off to the side. Two numbers that multiply to 42. So 2 times 21. We have 6 times 7. Now 6 times 7, that's interesting. So 6 plus 7 is 13. I need negative 13. So don't forget about the negatives. Two negatives always multiply to a positive. So negative 6 times negative 7. These are the numbers I'm looking for, because negative 6 plus negative 7 is negative 13. Those are my two numbers. I'm going to take those two numbers and I am going to place these numbers in the Punnett square. So in the Punnett square, I'm going to write two of them actually. The first one is just going to be a guide. Punnett square, the first term, top left, is always your a term. Bottom right is always your c term. Not just your a, not just your c, but the a term and the c term. The other two is going to be your b term split. So when you split it up into the two numbers that you found. So let's work this out. So in the Punnett square, we're going to put the a term, which is 2r squared, top left. We're going to put the c term in bottom right, positive 21. And this b term, we're going to split it up into negative 6 and negative 7. Now it has to add up to the b term, so it has to add up to negative 13r. So we're going to place r's on the negative 6 and negative 7. Now at this point, I do not have them actually in the directions, but the directions should state that we need to take your GCF, the greatest common factor, of each row and column. So what I'm talking about is from 6r, and don't worry about the negative right away, 6r and 21, what's the greatest common factor? The biggest number you can divide out of both. That's 3. Top two, 2r squared and 7r. What's the greatest common factor? 2 and 7 is 1. R squared and r is the smallest, so it's going to be 1r or just r. Then our greatest common factor of one of the columns, 7r and 21, and that's going to be, you can divide them both by 7. And the last, 2r squared and 6r. 2 and 6 is 2. And then r squared and r is smaller. That's always the greatest common factor. Now the last thing, when it comes to positives and negatives, if the greatest common, or if we're the next to the greatest common factor, if that number is negative, it'll always be a negative. So the 7 up top, the number that's closest to it is the negative 7. That's going to come out as a negative, so it'll be 2r minus 7 and r minus 3. Those are our two factors. If you multiply those out, you can look right now, you can say 2r times r is 2r squared. 2r times negative 3 is negative 6r. Negative 7 times r is negative 7r. Negative 7 times negative 3 is a positive 21. So it multiplies out to the 2r squared minus 13r plus 21. So factors meaning multiply. So now we're going to set each factor equal to 0. So we have our factors. And don't forget about this 3 up here. That 3 comes down and is out front. That is still a factor multiplied. So now the problem is totally factored out. We're going to set each factor with the variable equal to 0. I mean, if we set 3 equal to 0, that doesn't make any sense. 3 does not equal 0, so that is not part of our solution. We can set 2r minus 7 equal to 0, and we can find a solution from that. We can add 7 and divide by 2. So it's going to be r equals 7 over 2, and let's set that equal to 0. R equals 3. So our solutions are r equals 7 over 2 and r equals 3. All right, let's work on our next problem. So we're going to, the a is positive 1, so I'm going to add 35. There are no like terms. Equals 0. Let's do a times let's do a times let's do a times c. So 1 times 30. So there's no greatest common factor. I forgot that. No greatest common factor. We do a times c, which is 1 times 35 is 35. And what two numbers multiply to 35 that add up to the b? So we have our a, b, c. And the b is positive 12, c is positive 35, and a is 1. So what two numbers multiply to 35 that add to 12? That's 7 and 5. Let's put that in our Punnett square. A term is top left. C term is bottom right. Our 7 and 5 are going to go into the two other diagonal boxes. They have to add up to 12m, so it's going to be 7m and 5m. Let's take out our greatest common factor, our bottom row is 7. Top row is m. Last column, 5. First column, m. The 5 is positive, so it's going to be a positive 5 we're going to bring out. The 7 is positive, so it's going to be a positive 7. So our two factors are m plus 5 and m plus 7. If we multiply those two out, you would get m squared plus 12m plus 35. We're going to take these factors and set them equal to 0. and solve. So you'd subtract 5, you get m equals negative 5. You subtract 7, you get m equals negative 7. Let's do number 2. Oh. I'm going to subtract 84 to set the equation equal to 0. I am going to look for a greatest common factor. I see the greatest common factor is 2. I can divide each term by 2. I'm not dividing it and it's gone. I am dividing it and moving it out front as a greatest common factor. So you're undistributing it. Get x squared minus x minus 42. Really they're 1s, but 1 times x or 1 times x squared is just x or x squared. So now I have on the outside, I have a greatest common factor of 2. I'm going to factor the inside further. We have our a is 1, b is negative 1, c is negative 42. So we do a times c, what adds to b. So a times c is negative 42. What adds to b is negative 1. So what two numbers multiply to negative 42 that add up to negative 1? So I got 2 and 21 with a negative on one of them. That won't add to negative 1. We have 6 times 7. If I put a negative on the 7, it actually adds to negative 1. 6 plus negative 7. So 6 and negative 7 are going to be my two numbers that multiply to negative 42 but add to negative 1. Let's put that in a Punnett square. A term top left, c term bottom right, 6x. It does not matter the b terms where they go. Okay, go to your greatest common factors of each row, each column. 6 is positive, so it's going to be a positive 6. The 7 is negative, so it's going to be a negative 7. So we have x plus 6 times x minus 7. And we have a 2. Don't forget about the 2 on the outside. Equals 0. Now the 2 doesn't have a variable, so we do not have to set that equal to 0. The x plus 6, that factor obviously has a variable, x. We're going to set that equal to 0, and we're going to solve. And then number 3, we have, it's already in standard form. We're going to do no greatest common factor. We're going to do a times c, so a is 3, b is positive 11, c is negative 4. A times c is negative 12, so what two numbers multiply to negative 12? That'll add up to 11. That's 12 and negative 1. I don't expect you guys to come up with it that fast. We're going to have 12n and negative 1n. Greatest common factors of each row, each column. And then since the 1 is negative, it'll be negative 1. Since the 12 is positive, it'll be positive 4. We have 3n minus 1, n plus 4. Set each equal to 0. Solve. Here's a two-step problem. N equals 1/3, and subtract 4, you get n equals negative 4. All right, number 4. I'm going to subtract 50, no like terms. So I have 15p squared minus 5p minus 50 equals 0. Greatest common factor, there is one. You can divide them all by 5, all the terms by 5. So I'm going to take that 5 and undistribute it, take it out front. 3p squared minus 1p, or minus p, minus 10 equals 0. The 5 on the outside is going to stay there. My a is 3, my b is negative 1, and my c is negative 10. So a, b, c. I'm going to do a times c, which is negative 30, and then what adds up to negative 1. The two numbers that multiply to 30 have to be 1 away if it's going to be negative 1, so it's 6 and 5. Where do I have to put the negative to make it add up to negative 1? I got to put it on the 6. So now I have Punnett square I have 3p squared minus 10, negative 6p, and 5p. Greatest common factor is 2p, 3p, and 5. The 5 is positive, so plus. 6 is negative, so negative 2. We have 3p plus 5, p minus 2, and let's not forget about the 5. The 5 does not have a greatest common factor, or doesn't have a variable with it, so that is not going to be part of our solution. Or it's not going to be any kind of not going to have anything to do with our solution. We subtract 5, divide by 3, and we're going to get negative 5/3. Add 2, and you get 2. On the back, we'll do these in class. I'll do some more like